Another trend is Open RAN, which in plain language is the ability to mix and match several vendors' hardware and software together in ways that wasn't possible before. We expect this to be financially beneficial for the operator, but it introduces significantly more complexity into the network and the business of running the network. These trends mean that the typical mobile network is more complicated now than it has ever been. And this has very real implications for testing strategies. We're going to talk about how operators can adapt their testing processes to address these new challenges. But first, let's spend a couple minutes looking at how things are done today. This is a dramatic oversimplification, but the left side of this slide shows traditional network architectures in the world before 5G. Networks were purpose-built, highly vertically integrated, and generally supplied by a single vendor. Sure, operators had multiple vendors within the same networks, but the interface points were minimal and pretty tightly controlled. Notably, there's only a handful of players in the game back then, and you can see the usual suspects here. The advent of 5G, and especially Open RAN, introduced a lot of new suppliers into the industry, as you can see here on the right. The incumbents are there, but there are new RAN vendors as well, like Mavenir and Bicells. Virtualization has brought several other companies into the mix, like Red Hat, Wind River, VMware, and opened the market to commercial off-the-shelf hardware suppliers like HP and Dell. Not to be left out of anything, the hyperscaler cloud platforms like Azure and AWS and Google Cloud are participating too, with many operators already working with them. A recent survey done by Jabil of 193 companies, 55% of them are considering Open RAN. Another 22 already have plans in place, and the majority of those will include the major public cloud vendors. So all this means that the combinations to test are increasing a lot. So let's take a closer look at why. Here we see the typical 4G network architecture with the enhanced packet core, the BBU, and RU. It's pretty straightforward, with the one really only real deployment question is where to locate the BBU equipment. Is it centralized with the core, or is it distributed with the RF equipment? The equipment and the suppliers are the same. In the world of 5G, the BBU is disaggregated, and its functions can exist in a variety of places on different hardware. These variations are called functional splits, and there are 8 major ones, although some are a lot more common than others. I'm not going to go into why some of them are used over others, except to say that the operator decides which ones to use based on a whole bunch of different factors and requirements and constraints, such as latency, QoS, traffic loads, and the available bandwidth for things like backhaul, mid-haul, front haul, and the cost and scale of the bits in the network. It's common to combine multiple splits into the same network to address different network site density and service offering requirements.